When dealing with electrical installations, understanding the National Electrical Code, or NEC, is crucial. The NEC provides guidelines for safe and effective wiring practices. Let's consider the scenario of using a reduced neutral conductor in a 2-pole multi-wire branch circuit powering 16 post lights. Each light consumes 180 watts, and they are evenly distributed with 8 lights on each pole, fed by a 20 amp GFI breaker. Number 2 aluminum use cable is used to mitigate voltage drop, and the question arises whether a reduced neutral, such as in a size 2-2-4 with 6 ground cable, is acceptable given the balanced load. Firstly, it's important to note what the NEC states regarding neutral conductors. Section 310.15 B4 of the NEC addresses situations where parallel neutral conductors are used. It specifies that the combined cross-sectional area of these parallel neutral conductors should not be less than 1/2 the area of the largest phase conductor. However, there is an exception provided in section 310.15 B4 A, which pertains to 2-wire branch circuits where the load is balanced. A balanced load is crucial in this context. It refers to a situation where the current in each phase conductor is approximately equal. In the given setup, with 8 lights per pole, each drawing 180 watts on a 2-pole circuit, the load is considered balanced. This balance is essential because it significantly reduces the current flowing through the neutral conductor. Now let's address the use of a reduced neutral. When a load is balanced, the current in the neutral conductor is typically much less than half the current in the phase conductors. Therefore, using a reduced neutral size, such as the 2-2-4 cable mentioned, can be a cost-effective and acceptable solution. It provides adequate capacity for the expected neutral current without causing unacceptable voltage drop. However, one should confirm that the reduced neutral is indeed acceptable. This is done by performing voltage drop calculations using the cable size, the load characteristics, and the circuit length. The goal is to ensure that the calculated voltage drop remains within acceptable limits. Generally, a voltage drop of less than 5% is considered acceptable, as it ensures efficient operation of the connected devices and minimizes the risk of overheating or premature failure. Voltage drop calculations are a crucial aspect of electrical design. They help determine whether the selected conductor size is adequate for the intended load and distance. These calculations take into account several factors, including the conductor material, length, current, and operating temperature. If the voltage drop exceeds the acceptable limit, then a larger conductor size is necessary to reduce the resistance and minimize the voltage drop. It's also worth noting that while a reduced neutral might be acceptable under balanced load conditions, it's essential to consider potential future changes in the load. If there's a possibility that the load might become unbalanced in the future, it's prudent to use a full-size neutral conductor to accommodate potential increases in neutral current. In addition to the NEC requirements and voltage drop calculations, local electrical codes and regulations should always be consulted. These local codes may have specific requirements or restrictions regarding the use of reduced neutral conductors. It's essential to comply with all applicable codes to ensure a safe and compliant installation. To summarize, firstly, ensure the load is balanced across the phases. Secondly, perform voltage drop calculations to confirm that the reduced neutral will not result in excessive voltage drop. Thirdly, consult local electrical codes and regulations to verify compliance. Fourthly, consider potential future changes in the load that could lead to an imbalanced condition. By following these steps, one can make an informed decision about whether a reduced neutral is acceptable for a particular application. Additionally, proper grounding and bonding practices are essential for electrical safety. The grounding conductor provides a low impedance path for fault currents, helping to protect against electric shock and equipment damage. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. It is important to remember that electrical work can be dangerous, and it should only be performed by qualified and licensed electricians. Working with electricity requires specialized knowledge, skills, and equipment. Attempting to perform electrical work without proper training can result in serious injury or death. Before making any wiring changes, it's always recommended to consult with a licensed electrician or refer to the specific requirements of the local electrical code for confirmation. Electrical codes and regulations can vary depending on the location, and it's essential to comply with all applicable requirements to ensure a safe and compliant installation. Understanding conductor sizing, voltage drop, and neutral requirements is essential for designing and installing safe and efficient electrical systems. The NEC provides valuable guidance on these topics, and it's important to stay up to date with the latest code revisions. By following the NEC guidelines and consulting with qualified professionals, one can ensure that electrical installations are safe, reliable, and compliant with all applicable regulations. Remember that electricity is a powerful force, and it should always be treated with respect. By following safe work practices and adhering to electrical codes and regulations, one can minimize the risk of electrical hazards and ensure a safe working environment. Before working on any electrical equipment, always de-energize the circuit and verify that it is de-energized using a reliable testing device. Use appropriate personal protective equipment such as insulated gloves and safety glasses to protect against electric shock and other hazards. Never work on electrical equipment in wet or damp conditions, as this increases the risk of electric shock. If you are not comfortable working with electricity, always hire a qualified and licensed electrician to perform the work. In addition to the technical aspects of electrical work, it's also important to consider the environmental impact of electrical installations. Choose energy-efficient lighting and appliances to reduce energy consumption and minimize the carbon footprint. Use sustainable materials whenever possible, and recycle electrical waste properly. By making environmentally conscious choices, one can help to reduce the environmental impact of electrical systems. In conclusion, understanding the NEC requirements for neutral conductors, performing voltage drop calculations, and consulting with qualified professionals are essential steps in determining whether a reduced neutral is acceptable for a particular application. By following these steps and adhering to safe work practices, one can ensure that electrical installations are safe, efficient, and compliant with all applicable regulations. Remember that electrical work can be dangerous, and it should only be performed by qualified and licensed electricians. Electricity is a fundamental part of modern life, and it's essential to use it safely and responsibly. By following the guidelines and recommendations outlined in this discussion, one can help to ensure the safe and reliable operation of electrical systems. Finally, remember that continuous learning and professional development are essential for staying up to date with the latest advancements and best practices in the electrical industry. Attend training courses, read industry publications, and participate in professional organizations to expand your knowledge and skills. By investing in your professional development, you can enhance your career opportunities and contribute to the advancement of the electrical industry. Always prioritize safety in all electrical work, and never take shortcuts that could compromise safety. By following safe work practices and adhering to electrical codes and regulations, you can help to prevent accidents and injuries. Remember that safety is everyone's responsibility, and it's essential to work together to create a safe working environment. By working safely and responsibly, one can help to ensure the well-being of themselves, their colleagues, and the community. If you have any questions or concerns about electrical safety, always consult with a qualified and licensed electrician or other qualified professional. Remember, when dealing with electricity, it's always better to be safe than sorry. It is also crucial to ensure that all electrical equipment and materials used in an installation are properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or This listing ensures that the equipment has been tested and meets established safety standards. Using unlisted or counterfeit electrical equipment can be dangerous and could lead to electrical shock, fire, or other hazards. When selecting electrical equipment, always choose products from reputable manufacturers that have a proven track record of quality and reliability. Read product reviews and ratings to get an idea of the experiences of other customers. Before installing any electrical equipment, carefully read the manufacturer's instructions and follow all safety precautions. If you have any questions or concerns about the installation process, consult with a qualified and licensed electrician. Regular maintenance and inspection of electrical systems are essential for ensuring their continued safe and reliable operation. Schedule regular inspections by a qualified electrician to identify and address any potential problems before they become serious. Inspect electrical cords and plugs for damage and replace them if necessary. Keep electrical panels and equipment clean and free of obstructions. By performing regular maintenance and inspections, you can help to extend the life of your electrical systems and prevent costly repairs. If you notice any signs of electrical problems, such as flickering lights, tripped circuit breakers, or burning smells, immediately investigate the issue and take corrective action. Do not attempt to repair electrical equipment yourself unless you are qualified to do so. Always hire a qualified and licensed electrician to perform any necessary repairs. Educate yourself and your family about electrical safety. Teach children about the dangers of electricity and how to avoid electrical hazards. Make sure everyone in your home knows how to shut off the power in case of an emergency. By educating yourself and your family about electrical safety, you can help to prevent accidents and injuries. Consider installing arc fault circuit interrupters, or RSIs, in your home to protect against electrical fires. RSIs are devices that detect arc faults, which are a common cause of electrical fires. When an arc fault is detected, the RSI will trip the circuit breaker, cutting off the power and preventing a fire. Arc fault circuit interrupters provide an additional layer of protection against electrical fires and are required by code in many areas. Also consider installing ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor areas. GFCIs are devices that detect ground faults, which can cause electrical shock. When a ground fault is detected, the GFCI will trip the circuit breaker, cutting off the power and preventing electrical shock. Ground fault circuit interrupters are required by code in many areas and provide essential protection against electrical shock. When using extension cords, always use cords that are rated for the intended use and that are in good condition. Do not overload the extension cords or run them under rugs or furniture, as this can create a fire hazard. Inspect extension cords regularly for damage and replace them if necessary. Always unplug extension cords when they are not in use. When working outdoors, be aware of overhead power lines. Keep ladders, poles, and other equipment away from power lines to avoid electrical shock. If you are working near power lines, contact the utility company to have the power lines energized. Never touch a downed power line, as it could be energized. Report downed power lines to the utility company immediately. In conclusion, electrical safety is a serious matter, and it's essential to take the necessary precautions to protect yourself and others from electrical hazards. By following the guidelines and recommendations outlined in this discussion, you can help to ensure the safe and reliable operation of electrical systems and prevent electrical accidents and injuries. Remember, safety is everyone's responsibility, and it's essential to work together to create a safe working environment.